and welcome to the first of two tutorials on the topic of equation of a straight line. This is such an important topic and introduces you to the whole world of functions and graphing functions on a set of axes. So in this first tutorial, I'll be giving quite a few simple examples to motivate the equation of a straight line, and then we'll end the tutorial by writing down the general form of the equation of a straight line, which is y equals mx plus c, which you've probably come across in your studies already. Then in the next tutorial, I'm going to show how to derive the equation of a straight line if you're given two pairs of coordinates that the straight line passes through. And we'll end that second tutorial by looking at an alternative form of the equation of a straight line, which I know some students find confusing, and I'll show you how to easily manipulate that back into the regular y equals mx plus c form of the straight line. So let's start with some examples. So I'm going to start with the straight line y equals x. I'm going to draw my axes so that I can construct a graph of y equals x. So this is the x-axis, and we've met this before really. This is the real number line that we met in the numbers tutorials. Here's 0 on the line, and through 0 vertically we have what we call the y-axis. And the idea is that for every single point on this x-axis, we want to draw a point above or below it, which is sort of given by, in this case, y equals x, or generally by some function. So this equation is like an instruction, and this equation is telling us for a given value of x, set the value of y, which is the height above or below this number line, set the value of y equal to x. So that's quite a nice simple instruction. So let's just do a few examples. If x is 0, the equation says, well, y is 0, so we have 1 point here. Let me just plot a few points here. If x is 1, the equation says y is 1. So for x is 1, we just go up 1 unit above the x-axis to y equals 1, and that's a point. If x is 2, the equation says y is 2. So we go up 2 units. And you see how we can construct essentially a set of points. If x is -1, the equation says, well, y is -1. So we go 1 unit below the x-axis, and so on. And so we have a set of points here, and what we can do now is pass a line all the way through them. I missed that one slightly, there we go. Because whatever value of x we choose, the equation instructs us to go that value above the line, or below the line if it's negative, and place a point. And by drawing this line, we're effectively covering all of those points. And this line then is a graph of the equation y equals x. You can see the line as a straight line. And that would probably be the simplest straight line that we could sketch, y equals x. Let's do another example. Let's imagine we have y equals 2x. I draw my axes, the x-axis and the y-axis. Let me just imagine I'm doing a few points here. There's the origin. So now if I choose x equal to 0, the equation instructs me to take a value of y which is 2 times x. So 2 times 0 is 0. So I have a point right on the line. If I look at x equals 1, the equation now instructs me that y is 2 times x. So 2 times 1 is 2. And I'm meant to go 2 units above the number line. If x equals 2, the equation instructs me to look for y 2 times 2 is 4. So I would go 4 units above the number line. And let's just do one more point. If x was -1, the equation says take y to be -1 times 2, which is -2. So we would be down here at -2. And you can see now that my line has to pass through this set of points. It's quite hard to sketch these when you're not allowed to tilt the paper, so just bear with me as I try to sketch this. This is very awkward. Definitely not up to my usual standards, so apologies, but that is meant to be a straight line. I guess I could use a ruler, couldn't I? Famous last words, but that's a straight line of y equals 2x. Now, very important, sort of obvious, but do you notice this line is a lot steeper than this line? Let's do another example. Let's do y equals 1/2 times x. Okay, here's my x-axis, here's my y-axis, here's the origin. Let me do some points as usual. Let me do 1, 2, let me do maybe -2. These points that I'm doing are to sort of give you motivation for why the straight line has the shape that it does. As you get more experienced, you'll be able to sketch the line straight away without doing this first step. So x is 0, y is 0, so the straight line will pass through the origin. If x is 1, I have y as 1/2, so I just go 1/2 a unit above at x equals 1. X equals 2, the equation tells me that y is 1/2 times 2, which is 1. So that will be 1 unit above. If x is -2, I have y as 1/2 times -2, which is -1. So I would be 1 unit below. Okay. As we're going to see in the second tutorial, if you want to define a straight line uniquely on a graph, you only need 2 points. So the fact that I'm doing multiple points is not really necessary, but it's just to, again, as I say, sort of motivate the straight lines that I'm drawing. Right, so I want to pass a line through these points. Obviously, I've missed this one pretty badly there. And that's the equation, y equals 1/2 x graphed as a straight line. And you notice this time, this line is much less steep than this one, which was less steep than this one. So obviously this number that multiplies x, which here was 1, the number that multiplies x is essentially telling us about the slope. Now, I do apologize. I had promised to do curly x's in these videos because I tend to draw a cross for x, which is lazy. And the reason that's lazy is because the times sign looks like a cross. Okay, so I can just draw a little cross there for 1 times x. So when you see something like y equals x, there is an implicit value of 1 multiplying that x. So let's do another example. Let's do y equals negative x. Okay, I'll do this one quite quickly. Here's x, here's y. If x is 0, y is 0. If x is 1, we're told by the equation is an instruction that y is -1. So if x is 1, y is -1. If x is, say, -2, we're told that y is -1 times -2. So if x is -2, let me just kind of do that down here. We're told that y is the negative of -2. That's like -1 times -2, which is 2. Okay, so y will be up here, and here's our line. This graph looks very much like this one, but sort of reflected. It has the similar slope, but the slope is negative instead of positive. So from all this, you can see that if we write y equals a number times x, and I'm going to call that number m, this m is the slope of the line. If m is a small positive value, we have a shallow line in this direction. If m is a large positive value, we have a steep line in this direction. If m is negative, we have a line in this direction. So, very important to remember that if m is positive, your line will have a slope in this direction, and if m is negative, your line will have a slope in this direction. So let me just do two more examples, then I'll finish with the general form of the equation. Let's just look at the equation y equals x plus 1. Okay. Now, this time, if x is 0, and we follow the instructions of the equation, we see that y equals 0 plus 1, which is 1. We see that if x is equal to 1, the equation tells us that y equals 1 plus 1, which is equal to 2. And we see if x is negative 1, the equation tells us that y is negative 1 plus 1, which is 0. So now we have this line for the equation y equals x plus 1, and you can see it looks very much like y equals x, but it's been shifted up by 1 unit for every value of x, and it passes through the value y equals 1, because you see when x is 0, we can see where this line will cut through the y-axis. We'll talk more about this through the set of tutorials as we go, but it's always worth bearing in mind the y-axis is essentially the line x equals 0, and the x-axis is the line y equals 0, because every point on the y-axis has x equal to 0, and every point on the x-axis has y equal to 0. That can be quite a hard concept to get when you're first doing this level of math, but it's so useful once you've got it. So it'd be obvious to you that when you have y equals x plus 1, that 1 will be the place where the line cuts through the y-axis, because the y-axis is the line x equals 0. So x equal to 0, y equals 1. And we'll do one final example. Let's do y equals negative a half x negative 1. See what we get. We're already expecting that the line is going to have a slope this way rather than this way, because we have a negative number multiplying x. But let's see what else happens. Well, let's set x to 0. Why not? The equation instructs us then that y is negative 1. Okay, so at x equals 0, y is negative 1. So the equation is going to pass through that point. Let's see what happens when x is 2. When x is 2, we're multiplying 2 by negative a half. So negative a half times 2 will be negative 1. Then we're subtracting 1, so we'll have negative 2. So at x equals 2, we're told to go 2 below the line. And then let's just take x to be negative 2. If x is negative 2, we have negative half times negative 2. A negative times a negative is positive. Half times 2 is 1. And then so we have 1, but then we take 1 from that, and we have y is 0. So these are 3 points on the line. We can just sketch all the other infinite number of points that we're not going to do one by one, but the line represents what we would have gotten had we done every single point on the number line. And that's the straight line for the equation y equals negative a half x, take away 1. It has the 2 features that we would expect. It has a shallow slope, which is in this direction, because the slope is negative. So it's going to have a line oriented in this direction, and it's shallow because the number multiplying x is small. And this extra term, -1, tells us that when x is 0, y must be -1, which indeed it is. So from all of these examples, we can motivate the general form of the equation of a straight line, which is a beautiful thing and so useful in maths and science. Y equals mx plus c. The m is the slope of the line, and remember, if m is positive, your line will be oriented this way. If m is negative, your line will be oriented this way. And c is the value of y when x is 0. You see, because when x is 0, regardless of the value of m, y will equal to c, and we call this the y-intercept. So I have known this equation for more decades than I would like to admit to, but I never tire of it because it's a very honest equation. It tells you exactly what's going on. Y equals mx plus c says a straight line of slope m that passes through the y-axis at y equals c. Now, as I say, in the next tutorial, we're going to derive this equation if we're given other information. If we're given 2 pairs of coordinates, we'll be able to derive the unique equation of a straight line that passes through those 2 sets of coordinates. And then we'll look at an alternative form of the equation of a straight line, which I'd say is a bit more formal, less transparent, and we'll show how to convert it into this wonderful workhorse, this very trusty servant of maths, y equals mx plus c. So I hope this tutorial's been helpful, and I'll see you next time.